All right, let's jump right into something that sounds like it's straight out of science fiction. We're looking at a new research concept that's, well, it's pretty wild. It's a cable that can literally float all by itself. This idea could completely flip how we think about transportation, energy, you name it. So let's dig in. So let's just start with this one big question. What if you could make a train or maybe a cargo pod just hover, float above a track using absolutely zero power from the vehicle itself? I mean, no engines for lift, no complicated power systems just to keep it off the ground. That's the core problem this whole idea is trying to solve. I mean, sure, we already have trains that levitate, right? Maglev. They are absolute marvels of engineering, just floating on these powerful magnetic fields. But here's the catch, and it's a big one. They are power-hungry beasts. They need a constant, massive amount of electricity for their onboard electromagnets, and they often need these super complex cryogenic cooling systems just to keep from overheating. And this really lays it all out, doesn't it? On one side, you've got our current maglev tech, with all its heavy, power-sucking, complicated machinery bolted onto every single train car. But on the other side, you have this new idea. A totally passive cable does all the hard work of levitating, which means the vehicle could be as simple as, well, a box on a string. It's a total shift in where you put the complexity. So what is this breakthrough? It's called the passive mag biooptic cable. Yeah, I know it's a mouthful, but the concept behind it is just beautiful. It's this single layered cable that's actually inspired by biology, and it's designed from the ground up to kill that massive energy problem that comes with levitation. So look, this isn't just some fancy rope. It's a whole integrated system. It gives you levitation with zero power on the vehicle. It has channels for data and diagnostics built right in. And get this, it can even heal itself. The real genius here is that it takes all the complicated energy-guzzling parts off the vehicle and puts them into the track, which is static and way easier to manage. So how on earth does this thing actually work? Well, to get it, we need to look inside. The cable is basically built like a synthetic organism. It has 3 different layers, and each one acts like a part of a body. You've got a skeleton, a nervous system, and a muscle. It's a really cool way to understand this super high-tech material. First up, you've got the skeleton. This is a ribbon made of carbon nanotubes, which is one of the strongest materials we know how to make. We're talking a strength of over 5 gigapascals, which is just ridiculously strong. This layer is the backbone, the core that carries all the weight and gives the cable its unbelievable toughness. Okay, next is the nervous system. This is a bio-optic channel that's actually grown from bacterial cellulose. You can think of it as a biological fiber optic cable. It can shoot light through it to transmit data or even power, but the really cool part is that it's packed with sensors that are always checking the cable's health, just like the nerves in your own body. And finally, this is where the magic happens, the magnetic muscle. This is a soft fiber that has tiny little chains of magnetite, a natural magnetic mineral, embedded inside it. So when you put this cable over a simple track of permanent magnets, this layer just naturally pushes away. It repels the track and creates lift. It's a completely passive thing, no electricity needed on the cable, it's just physics doing all the heavy lifting for you. And just when you thought it couldn't get any cooler, this thing can heal itself. If tiny microcracks start to form, you can shine a specific beam of light on it, and that triggers a chemical reaction that seals the crack right up. It's a solid-state repair, so no messy gels or anything. Just a quick field repair using a flashlight, basically. It's an incredible feature, totally inspired by biology. Okay, so you have this incredible, self-healing, levitating cable. How would you actually use it? Well, the researchers are proposing 2 main ways to use it. One is super practical for right now, and the other is a little more out there. The main application is ground transport. So you lay down a track of permanent magnets. The vehicle, which is really just a simple carrier for our biocable, just floats over it. No noise, no friction. And since you don't need any power for lift, you can push it along with simple motors in the track or even just tow it. And the target speed they're thinking of? A mind-blowing 600 kilometers per hour. Now for the more exotic idea. They're calling it the ascent mode. Remember that optical channel, the nervous system? Well, you can use it for more than just data. If you shine a really powerful laser through it, the radiation pressure, that is, the tiny physical push that light actually has, could theoretically be used to help very small things climb up the cable. But, and this is a really big but before we all get carried away dreaming of space elevators, let's bring this back down to Earth. To lift just 1 kilogram against gravity using only light pressure, you would need 1.5 gigawatts of power. That's pretty much the output of a large nuclear power plant. So let's be clear, this would be a super specialized tool for lifting tiny sensors or little inspection robots, not people or cargo. So, okay, let's pull back and look at the big picture here. Why is this so important? This isn't just about a slightly better train. This is a potential paradigm shift. It's about completely rethinking where we put the energy and the complexity in our transport systems. When you put them side by side like this, the difference is just crystal clear. Conventional maglev puts all the hard stuff, the power systems, the cooling, the maintenance, on the moving vehicle itself. This passive cable system, it does the exact opposite. It makes the vehicle dead simple and super low energy because it shifts all that complexity to the track, which is fixed and much easier to take care of. And that really boils down to 3 huge wins. First, you get massive gains in energy efficiency because you're not wasting power just to hover. Second, your vehicles can be radically simpler, lighter, and way cheaper to build. And third, you get this beautiful integrated system that handles the structure, the levitation, and the data all in one elegant package. You know, this quote from the paper just perfectly sums up the entire philosophy here. It's all about efficiency and unification. They're not just trying to make a better part, they're trying to create a smarter, more integrated system where one clever cable does the work of a dozen complex machines. And that really brings us to the final thought. Now look, this is still a concept. There are massive engineering challenges to overcome, for sure. But the vision here is so powerful. A transportation backbone that's silent, incredibly efficient, and can even heal itself. This isn't just about faster trains. It's about totally reimagining our infrastructure from the ground up. So the real question is, could this be the key to building the sustainable, low-energy supply chains of the future?